Welcome to Code Candid, Conversations with Tech Masters, where we explore India's supercomputing journey to build a smart society. Today we have Dr. S.D. Sudarsan with us, who is the Executive Director of C-DAC Bangalore. Sir, it's an honor to have you here on the show. We welcome you on Code Candid.
Sakurji, it is really a pleasure to be talking candidly about the current technology that India is taking a great leap forward, and it is indeed an important activity to reach out to everyone so that people are aware of what is happening. That gives confidence,
Right.
and it's a pleasure to be on the show, and it's a privilege to be called a tech master, whatever level that we are.
You are, of course.
But definitely we are trying to do a great job in terms of our tech journey,
Right.
and we'll see what all can be shared as you, because you are going to shoot the questions.
So, sir, let's start broad. C-DAC has been working across domains, from supercomputing to AI to quantum computers to Internet of Things. So, is there a kind of a an overarching theme that connects all of this? And how do you see, C-DAC connecting all the dots here?
A fantastic question. I think the answer will be a little bit more detailed, because now you are asking a broad spectrum. In fact, the journey of C-DAC started in 88 officially, though the seeds were sown in 86, I believe. So 88 is when we started. That time the task was a mission. The way ISRO came, we need a rocket for launching a satellite our own. Similarly, we had a mission when we were denied a supercomputer, and we were told, if we are denied, we will build, let us build. That was the mission. Unfortunately, the young team at that time, led by now Padma Bhushan or Dr. Vijay Bhatkar,
Okay.
they came up with a Param series of computers.
Right.
First time built in India with no US chip, and it was second best in the world when it was tested, and I made an attempt, and it was done 6 months ahead of schedule. That was the commitment our Indian scientists and engineers had.
Right.
Then for about a decade it continued into the supercomputing, HPC as the key area. 2000 was an I will say a landmark moment in the country. We started, India came to world stage
Right.
with the Y2K for IT. But what was not publicly noticed was a new term got coined, ICT, Information Communication Technology, and the government did some amazing actions. So they connected all the similar technologies of Ministry of Electronics and IT.
Okay.
There was something on electronics development called the ERDCI, Electronic Research and Development Center. They were focused on electronics research. Then we had a software technology center called the National Center for Software Technology.
Right.
So they were working on software architectures, complex software and things like that.
Right.
Then there was another organization called the CEDT, Center for Electronics Design and Technology. They were focused on product design. And then many of them got merged into C-DAC as a single entity. So in 2000, C-DAC changed its shape from just a HPC as a compute provider,
Right.
to someone who will provide the electronics, who will provide the software, who can look at the product as a system.
Right.
So the 2002 to 2008 was a journey of consolidation, and subsequently we became broad. So today what we are looking at is the way India is looking at a holistic growth. We are looking at not computer as a compute. Today if you look at a compute, it is saying that I have a supercomputer, but for what? It is public money. So we are actually looking at how it can benefit the public. So we look at the applications. It could be healthcare, it could be drug discovery, it could be weather forecasting,
Right.
it could be urban modeling, it could be
many
water,
use cases.
it could be computational chemistry, cyber security. So we have a bunch of applications that are being developed on top of the system.
Right.
And the application developers need a set of software called system software. We develop that.
Right.
Now, earlier we were actually designing the system. Today we not only design, it is manufactured in India. We have Rudra series of HPC computers.
Right.
And for that, today if you look at AI is the buzzword, current jargon. So all the compute today needs input for AI to be trained.
Right.
And the training depends on the sensors or inputs that come from. So we need to work on lot of IoT sensors so that the right data comes to the training module. So we have solutions in IoT sector. And then all these depend on the actual chip. So we have a VLSI design team. We have a program under India Semiconductor Mission called the Design Linked Incentive, and also Chip to Startup.
What is it called?
Design Linked Incentive.
Okay, design.
This is for startup and MSME to do chip design in India, completely Indian.
Okay.
And for that we need amazing manpower. It's a cutting edge technology. We have a Chip to Startup program. Today 300 plus institutes, over 80,000 people are being trained on chip design, and it is going to scale up further. So we are starting from at the lowest end chip design to a sensor, to a motherboard, to a system with a software with application, and all of them has to happen along with cyber security, because security, IT Act, DPDPA, they are also under our Ministry of Electronics and IT. So that is a thing that is taking care of the privacy, safety, security aspects of it. So all of them are now interlinked, and they all have to be accelerated using AI.
True.
So we have teams that are using AI for training, using AI for inferencing, using AI for speeding up our activities.
Right.
So that is how suddenly C-DAC is very broad. We are today at 12 locations in the country, covering a plethora of technologies. So we are very confident India is moving in the right direction, and we are putting our best foot forward to contribute to the journey of the nation.
The corporate office is in Pune, right?
Yes, our corporate office is in Pune. Pune also has one of the largest C-DAC centers.
So speaking of supercomputers, you rightly said from Param to Rudra, and now exascale computing also. How is C-DAC building India's next gen computing? We are talking about supercomputers. IBM has recently launched one. Then there is so much going on across the world in this field. So how is C-DAC building that kind of scale for India?
Again, very challenging, and you have touched some part of our heart of C-DAC, not just me. Essentially what India is looking at is, in today's scenario, geopolitics and other things put together, unless we are technologically independent and sovereign,
right,
collaborations and interdependencies does not happen.
True.
We should be at equal footing to be able to negotiate with our international collaborators. So consciously what we have done is, today we started with Param is the name of the system.
Right.
Rudra is the name of the compute board, HPC computer, motherboard. We call it Rudra. So we started with Rudra 1, that was based on a Intel NVIDIA architecture. NVIDIA is the GPU and Intel the CPU.
Okay.
Then parallelly we started a Rudra 3 program, which will use AMD chipsets. And we have another program by which we are developing a RISC-V based HPC using ARM, which is another IP provider in the HPC, ARM, ARM. So we are coming with a OM processor, which will be India's own HPC, where the chip also is designed by India. Then we are now working on the next variant, which is the upgrade of our Vega series of RISC-V processor. So we will scale it up for HPC grade.
Right.
So our target is in the next 3 to 4 years, we will build a exascale system where we will have not just one, we will have 4 motherboards to compare. There is a Intel based design, there is a AMD based design, there is a RISC-V ARM based design, and there is a C-DAC's own Vega based design.
Vega based.
We will
right.
compare and contrast, and we hope our system will be good enough so that the next exascale system will have Indian IP
Right.
completely owned. That is the journey we are embarking on. Currently, it is in progress.
It's in progress.
Yes.
And by when can we expect this?
So when you talk of HPC, the future HPC is not only the CPU as they call it, central processing unit,
Right.
but today is the world of AI. So everyone talks about GPU, graphical processing unit,
Yeah.
and then people are talking about AI accelerator chip. You also heard about quantum mission. So we are also believing that quantum has a role to play. So there will be a quantum processing unit QPU,
Right.
and at some point we may have neuromorphic processors
Right.
and other things also. So we believe in the next generation, it will be a bunch of processors that will be part of it,
Lot of
and
them,
all
yeah.
of them together will decide what task can be performed on which processing unit,
Right.
so that overall we get the benefit of energy, speed, compute power, time reduction, all those things. So given that, we are working on a set of chiplets that will
Right.
have our own AI accelerator, our own GPU, CPU and so on. That is what we are doing. We are also talking about when these things are working,
Right.
they have to talk to each other. One server is not there. There are multiple servers, multiple racks. They have to be connected.
Right.
So this interconnect also, we have our own solution. We have a Trinetra interconnects. So even connecting between the servers, we have our own IP now.
That is
So-
wonderful, I think. Yeah.
This is what we are going forward.
I think you covered a lot, from making Make in India chips to all these things coming together and having the right kind of, use case. I think that would be really important for the sovereign supercomputing, if we go forward. So coming to the next part, the security part of the quantum. What do QSIM and Quniverse, actually mean for securing India's data networks,
Yeah, thanks, Vas. Now it is
Yeah.
very close to C-DAC Bangalore, where I come from.
Right.
In just before COVID started, Ministry of Electronics and IT, they approved a project called the Center of Excellence in Quantum Technologies.
Right.
That time the quantum mission was not still launched. MIT funded a project. There were three major institutions: C-DAC, Indian Institute of Science IISc, and Raman
IISc
Research,
Bangalore.
IISc Bangalore, and Raman
Right.
Research Institute Bangalore.
Okay.
So we experimented on several quantum technologies. As part of it, fundamentally Professor Apurva Patel from Indian Institute of Science, using his students, he developed a basic quantum simulator
Okay.
as a student project. Then we found it to be very amazing. That was the right thing we needed. Then we collaborated very strongly with IISc, C-DAC and IISc Bangalore.
Right.
Then the QSIM, we upgraded to a software that can be used by everyone, not just a demonstration as a project. Then we ported the software on a GPU, graphical processing unit, so that we can, in fact, a qubit requires a huge compute power, a quantum bit qubit.
Right.
So when we ported, we called it QSIM. So it was a quantum simulator.
Okay.
Then subsequently, last 7 years, we have done several projects in quantum. So each project, we had to test it using a simulator before
Right.
we realize the hardware. So then we thought, why not we integrate all the simulation into a larger umbrella? That is why from basic we convert into quantum universe, Quniverse.
Wonderful. Yeah.
So the Quniverse is an upgraded version of QSIM.
Right.
And today our Quniverse supports several quantum algorithms, several quantum digital gates. It also allows users to contribute their algorithm to our Quniverse
Right.
through what we call an SDK approach. It's a software development kit. So somebody does a new thing, they can add it to the platform. So now it has become a national platform. And today we have 15,000 people who are using
15,000.
Quniverse. Yes.
Yeah, that's a lot.
And it's a gaining popularity by the day. Now lot of academic institutes are working with C-DAC to offer quantum as a master's program, as a minor or as a specialization. Some are even contemplating a B.Tech in quantum computing.
Right.
The Universe is the platform of choice. And we also did one very good thing. In our Universe, not only you can test what we call logical qubits, which everyone does.
Right.
We also have connection to several physical quantum computers.
Okay.
So I can actually check whether my quantum simulation
Right.
works on a real quantum computer, because each
Right.
qubit physically when done is different in character.
True.
And technology wise also it can be based on photonics, it can be based on superconducting, it can be ion trap. There are many technologies. So what has happened is today Quniverse is giving access to real physical qubit for checking. It also allows you to add my own contribution to the Quniverse platform. And the basic usage is free of cost. You have to register, and we also offer training certifications on that.
Those are all free.
Training, some of them are free, some
Okay.
of them are paid.
Okay.
We do even certification programs in that.
Online.
Online, and many colleges do it physical because they want the faculty to get a hang of first-hand
Right,
experience, so that when they teach with confidence. So
Right.
we are working on various aspects of Quniverse, and to support the Quniverse and for people to know, we also have a quarterly publication called the Quantum Vibes.
Quantum vibes.
Vibes.
Okay.
So last 2.5 years, it has been available every quarter.
Okay.
So it talks about India's journey into quantum, and every issue has got a thematic thing. It can be on sensing, it can be compute, it can be computing, and then it has interview like the way we are discussing here
Right,
podcast.
right.
We have one expert who is demystifying a particular topic on quantum, on each issue. Then what are the international developments worthy to note?
Okay.
What are the programs one can attend, conferences, trainings? So we cover a lot.
It's in a form of a blog or a
It's
magazine?
a magazine.
Okay.
Digital subscription is free for all.
Okay.
One can download past issues.
All right.
Yes, it's every quarter.
Great that you talked about quantum in such detail.
Yes.
And I'm here tempted to ask you a question. I spoke to Klaus von Klitzing, the Nobel laureate, a few years back, and then it was in 2019, I think, and he told me that, we won't see quantum computers in market for next 10 years at least. Yeah, so, what do you know, with all the advancements in quantum since then, we are in 2026, how do you see that thing going, will we ever see quantum computers being used by, common people and not just inside the institutes?
Yeah, I'll answer in 3 parts.
Sure.
So first one, more of a pun intended. Probably the Nobel laureate talked 10 in binary.
Right.
He meant 2 years, not 10 years.
Okay, yeah.
Okay. Second, as we speak, at C-DAC Bangalore, C-DAC is building a 108 qubit quantum computer.
Okay.
As I speak. Installation is going on. So in the next couple of months,
Right.
We should see a 108 qubit quantum computer running in India.
Oh.
Yes, that is in terms of the real quantum computers and for there. And this is the 8th such a facility across the world, as I understand.
Right.
There are claims above 108, definitely they are there. But many of them, you get access remotely, you cannot have it. This is something we will be owning it, we will be operating it.
Right.
It is not operated by somebody else. I am not a user.
Right.
So India has a quantum computer where we can play around with the quantum computer, both in computing, also on the components of because the entire system belongs to us. Whether common man can use it, that is where now the questions are being debated, because to solve any advantage or useful program for a common man to use, for applications, real applications, with real quantum computers, not simulation, it is a couple of years, maybe 3 to 5 years away.
3 to 5 years.
But is for real applications using real quantum computers.
Right.
But today, if you want to do any simulation or any kind of quantum algorithm using a quantum simulator. We are already there.
We're already there.
We are already there.
Okay.
Today we are able to demonstrate some of the advantages. We already have systems that can simulate up to 35 qubits in simulator itself.
Right.
There are many programs that are working in this area.
And even 3 to 5 years is not a very long timeline.
It's not a long
I mean, for quantum computers, for a technology like this, I think everybody is kind of watching out for this space. Yeah.
Because we feel definitely there will be some breakthroughs which people are thinking it is because of physics, it is because of the manufacturing technology limitation. The way semiconductor now we go from 2 nanometer to 1.8 is a challenge because we are crossing a boundary or a threshold, something like that.
Right.
So quantum also, but I am very confident with the kind of talent we have, both in India and across the globe.
Right.
Some concept which is considered unbreakable or unbreakable
Right.
will be breached, and we will be faster than what everyone is predicting.
Wonderful. That would be great to see. Coming back to the security and quantum, on a more everyday level, how do systems like Rakshak DNS and X-Shield, for that matter, X-Shield 360 you have, so they protect regular internet users like me and you. Yeah.
Okay, so there are two things about quantum, maybe three things. I will first say the first part. Quantum inherently has something they call no cloning theorem. When you say no cloning, in a way, most of the cyber attacks, if you look at it, I get a copy of the data that is passing. I make a copy, I analyze till I break.
Right.
It is one of the most common. There are other attacks, but this is one of the most easiest one. I just gather, we keep harvesting whatever communication. At some point, I break. Because of the no cloning theorem of quantum mechanics, in quantum, any communication, if somebody intercepts, communication stops.
Okay.
So there is no way data will be exchanged if there is a third party monitoring.
Right.
We call it generally Bob and Alice talk to each other and Eve is the dropper. But here it is not possible. So inherently the basic communication is safe.
Okay.
By quantum property. It is guaranteed by physics, laws of physics. Now the second aspect that we are looking at is how do X-Shield and Rakshak DNS, which are protecting using current set of cyber attacks, protecting it. What happens when quantum comes?
Right.
So we already have post-quantum cryptography algorithms in place. And as I speak, our Controller of Certifying Authority and Ministry of Electronics IT, they have funded certain projects to develop PQC algorithms to support our public key infrastructure so that the digital signatures will remain protected from quantum era computers.
Okay. So that is already there.
Already in place and in the lab they are all working. Now it has to be worked out how to roll out, because rolling out is a different exercise than developing a technology.
True.
Because it is upgrading everyone, standards to be adopted, procedure to be changed, SOPs to be adopted, people to be trained.
Right.
That's a different game. But the technology for PQC for public use is in place. Similarly, the speed at which it has to be done also becomes very critical because communication speeds are increasing.
Right.
So we are also working on the implementation of such algorithms in hardware, so that it is not a software, it is hardware IPs, so that it can happen very fast, very quick in real time. So that is also work is in progress. Then third one that we are working out is both Ministry of Electronics IT and the National Quantum Mission.
Right.
They have among many groups, one technical group works on what we call hybrid computing.
Hybrid computing.
When we say hybrid computing, we combine traditional computing, AI computing, quantum computing. Maybe you can say CPU, GPU, QPU, all of them put together.
Wow.
So each one will help each other to accelerate with the right partitioning. So the hybrid computing technical group is led by C-DAC Bangalore.
C-DAC.
So when the 108 qubit computer comes, we are going to connect it to our HPC servers. So we will have a hybrid compute available for experimenting and making it faster and be prepared for PQC.
Okay.
The last question that remains where we need work to be done, I will say we are very early in the stage,
Okay.
is actual quantum cryptography. Because
Quantum
PQC
cryptography,
is
right,
protecting classical algorithms against quantum computers.
Okay.
But do we have quantum itself? Can it have crypto? What is to be done? I think that is a journey to start.
Wonderful, yeah. So now coming to the day-to-day gadgets, like our cars and everything else, they are becoming smarter, right? So how do we see C-DAC's PKI for Internet of Things, helping us keep these smart gadgets safer from hackers? We have had so many cases recently of these gadgets getting hacked, right? So how do we use this PKI infrastructure for IoT to help?
Very good. In fact, India's digital, we are talking about India becoming the larger and larger economy in the world. If you look at sector-wise, automotive is the #1 sector for economic contributions.
Right.
So we are aware of it. So what we have done now is we are creating an ecosystem which is bringing benefit to each of the stakeholder. I will take a couple of minutes to explain. So today most of the cars have at least 100 ECUs.
What is an ECU?
Electronic control unit. Basically everything is controlled by a smart system.
Right.
There is a controller which takes care. So today mechanic does not do screw. They just connect a test equipment. They say this module is faulty, replace.
Right.
Now whether the module is original or not, trustworthy or not. Similarly, the software update over the air. We have heard about autonomous car being hacked or remotely controlled. Right. How do we handle all that? So there is a software involved, there is a hardware involved, but they are all smart. It is no more dumb mechanical components. Right. Everything is becoming smart. So IoT is becoming part of the entire automotive ecosystem. So currently what we have done is, we have a setup which will actually demonstrate if you come to our C-DAC Bangalore, where each of the automotive part, they have major parts, there is a steering control, there is a gear control, like that. There are a number of sub-modules.
Right.
Now today each of them, since there is a chip involved in it, we are putting a digital signature in it.
Digital signature.
Yeah,
right.
the way we do UPI transaction,
right.
the way we do any digital transaction, we are signing each of the hardware element with a digital signature.
Digital signature.
What it does is 3 things. First of all, the vehicle, if it uses any part that is not digitally signed or authenticated, including software update, it won't update. Okay. Or if somebody has updated, since it does not have a valid certificate, the dashboard will indicate and vehicle will not start.
Right.
And the message will go to the concerned stakeholders. So that way, any break-in or any component that is not whitelisted cannot become part of the vehicle, #1. Second, as a consumer, today if I go for servicing or repairing my vehicle,
right,
I get a bill. I never know whether the components are replaced or not.
Right.
I trust. Whether the replaced components are original or not, I do not know, I trust.
True.
But with this digital signature, I will exactly see what component is old and new, because certificates will be shown.
So that will be traceable.
So yeah, so as a consumer, I know what I paid. See, the concept is today in security, it is called the zero trust architecture.
Right.
Because anyone can be hacked, anything can go wrong.
True.
So every time you have to check whether everything is in order.
Yeah.
So anything that is changed, I will get an updated list of inventory of my vehicle. What are the components? So I know exactly whatever is changed, then I will know what got removed, what got added, and why I am paying for it. Time-stamped and the integrity is guaranteed.
Wonderful. Yeah.
So this is for the consumer who is paying. Now for the supplier, I did lot of R&D to produce a particular component.
Right.
Now somebody simply makes a duplicate component, comes into market at lower cost.
Right.
Killing the innovation effort, everything. And also somebody will think I bought this branded equipment or component. but the shop owner or the dealer cheated me with a duplicate component,
Right.
knowingly or unknowingly. Now the brand, my brand is getting damaged, right? Because the
true.
component carries the brand of X,
Exactly.
but it is a duplicate component. So X brand value also loses.
Hmm.
But with this, only my signed devices can be added. So nobody can come and damage my image. So as a supplier, I am protected.
Right.
Now as a dealer, nobody can doubt. The bills are generated. I don't have to doubt my dealers. Today, why we go to a certain dealer repeatedly? Because I have been coming here regularly. Here I know the mechanics are genuine, dealer is genuine. I don't go to a new dealer.
Right.
But once it comes, I don't have to worry. Every dealer is a dealer, because if a original equipment manufacturer of the vehicle
Right.
says X and Y are my dealers, both are equally good, right? Quality control.
True.
So I should be able to conveniently go whichever is nearest. So this also brings trust among the dealers. So we will be making the entire ecosystem guaranteed with certified components, no duplicates, no cloning, nowhere integrity can be compromised, which will add a huge layer of trust for people to put money on technology and own. Because
Right.
when if I own this car, I know every component is genuine. I know every component is valid.
Right.
And if something goes wrong, I can actually take the original supplier to task, saying that
Right.
you said this, see your component only is running, now you please fix it.
Right.
So this is the way things are changing. So PK for automotive we are doing, but automotive, as I said, being one of the number one, but this is being applied across multiple domains.
Right.
Yeah.
So good to know, so many safeguards are being put in place when it comes to, securing the trust of the consumer.
Yes.
Yeah. And C-DAC is at the forefront of it. Now coming from cyber to more physical
Okay.
world, when it comes to efficiency, making systems efficient, how are smart energy meters, and water networks, right, helping cities cut theft and wastage of resources?
Very, very good, Sakurji. I will start with water first.
Sure.
India actually, we had a project almost a decade ago to develop smart water technology. It was an R&D project because India traditionally, the way drinking water is supplied to people,
Right.
there is a stored water for supply, or if there is a running water, there is a pump. The person from the board, Public Health Engineering Department comes, he switches on the motor, water is supplied.
Right.
Sometimes it is over a tank, valve is opened, water is supplied. Simple.
True.
What is the quality of water at the time of supplying? Nobody knows.
Nobody knows that.
Because
right.
there can be a bird for drop in that water,
Right.
or some contamination, or in the pipe water gets mixed, the sewage water
True,
mixed
true.
with
It has
drinking
to
water.
pass through so many
channels
yes,
till the end user gets it on the tap. So far what was practiced was the stored water on a periodicity depending on the state and all, typically once in a week or once, they will take a sample,
Right.
take to your lab, they will test the water is good quality. Now it is assumed it is 2 weeks it is maintained.
Right.
Every 2 weeks they test it, or every 3 weeks they test it weekly. That was coming. So we wanted to change it in that project. Can we actually check quality of water at the time of delivery? Because that is when I am going to consume.
Exactly.
At that time it should be portable, not when it got stored 2 weeks ago.
Right.
So we did a project.
It's the other way around.
So
right?
yeah, we decided some technologies. Well, industry was working on metering because they wanted to charge for volume of water.
Water, right.
But the quality was not part of it because metering was the easiest. Measure the volume,
True.
bill them.
Build them, right.
That is, water. It became across most of the cities. This became common. When we did, we had a quality parameters also. We looked at certain international standards.
Right.
We also looked at the sustainable development goals of the UN. So we took all these things. Then we decided to work on pH, chlorine, turbidity, dissolved solid particle, and so on. There are 4 or 5 parameters.
Parameters, right.
So we created a bunch of systems that can measure on the fly at the time of delivery.
Okay.
Then the next question came, now how to make it reach the end user?
Right.
Because water is a subject controlled by the public health engineering departments in the states.
True.
They have to now adopt it. There is a cost involved, there is a training of manpower involved, there is awareness to public involved.
Right.
Because when you charge public, India is used to free water.
Yeah.
पानी के लिए पैसा मांगता है. No, that was a typical dialogue we get. How do we generate? So there are a lot of operational issues, societal issues and all. And then we also thought if you do a transfer of technology, then it will be owned by one company or two company. Instead, our ministry, electronics, tied with Jal Jeevan Mission, Ministry of Jal Shakti, we ran a grand water challenge.
Okay.
So we asked as an open challenge, anybody who feels how to give quality water, please give your ideas.
Okay. It was a kind of a hackathon.
Yeah. So hackathon type. Interestingly, we did not anticipate. We got 200 plus applications.
Wow, that's huge.
That was amazing for a country where we thought water nobody bothered.
Right.
So when it happened, then we had an ideation round. This 220 we scrutinized. There was a jury committee that formed. From there we selected some 10 companies out of 200. 10. Yes. And those 210 were given as seed money as a grant.
Okay.
So with that money we told them, whatever you told, please create a mini prototype.
So this was for a prototype you had
developed? Yeah, you develop so that you are incentivized.
Okay.
Otherwise I have my own timeline. Instead we said within this period if you develop.
Right.
Then what we did with the technology C-DAC developed, we created a reference test bed. We have our own developed systems.
Right.
These are R&D, so one-time development little expensive, but we made a system. And we made a parallel system where each of the 10 companies came. Physically they brought their meters, their sensors.
Right.
They put it alongside. So we created a water test bed, smart water test bed. So we had two clean water tanks, one tank to collect, then add chlorine, reduce chlorine to see the functionality and things like that. So over a 3-day period, these 10 were evaluated physically with their own systems. They came to Bangalore, each one was given half a day time.
All the projects were evaluated?
Yeah, all the 10 were evaluated. Each one had a very unique ideas. And we also learnt, they also learnt. It also allowed all the 10 companies to talk to each other.
Right.
So that there is a knowledge exchange happening.
Exchange, exactly. That's important.
And then from there, we selected 4 of them.
Okay.
These 4 were given 100 villages across the country. Okay, again in water, a village is defined by a different parameter, not like a way we call village as a village. Because village wise fund has to be allocated.
Okay.
So for them a village is about 250 taps.
Okay.
Will be counted as one village.
One
because
village.
They have to, budgeting wise they need to have a number.
Right.
So if overhead tank serves 500 connections, it is 2 village.
Okay.
It makes sense. Though technical, these are little technical, but that is how system
from an evaluation
runs.
point of view,
and funding also. Tomorrow government says I am funding 100 village. What do you mean by 100 village? A village can be 10 people, village can be 10,000 people.
10,000 people also.
So that is a standard available in government. So 100 villages were chosen across from Ladakh to Manipur to Gujarat to Tamil Nadu. It was covering entire spectrum of the country.
Okay.
And these 4 were given 25 so-called water villages each.
Okay.
They actually went, implemented their system. They were given an additional incentive to go to the field. And they are running, and the local public health engineering department or whoever is responsible for water. Some places it is water board, some places it is public health engineering.
Right, PHE.
We got them involved. They were part of it. So in the end, it was running for some time. Then we gave grand prize to the top 3. The 4th one was also so good. They were also, all the 4 were given prize. And government actually purchases things through something called government e-marketplace, GEM we call it.
Okay.
So we introduced as C-DAC a new category in GEM for smart water systems. Otherwise it was not available.
True.
And then these people, we also mentored them with our technology so that their technology becomes better and better. And today we have more than 3 Indian vendors with almost 60+% indigenous components. Smart water systems are rolled out across the states. We even help them prepare a smart water tender. Each state a draft tender was done.
Right.
Interestingly, the India has something called a water manual.
Water manual, yeah.
Yes. So almost after couple of decades,
Right.
it got revised 2 years ago. For the first time, the water manual has 2 chapters on IoT and meters,
Oh,
where
nice.
C-DAC contributed in a very big way. So
Right.
today our water manual has IoT and smart water sensor as part of it.
so soon
So
we may see this technology.
It is already being rolled out
rolled
step by
okay.
step. That is what Har Ghar Jal, Jal Jeevan Mission,
Jal
they are
Jeevan
doing it.
Okay.
But I think we are very proud to have contributed on the water front there.
Wonderful.
And now we are going beyond just this drinking water to something called one water. Then why it should be only drinking water? Industrial effluent, sewage water, everything is water. Sea water.
True.
Ultimately, water has some properties. Then for consumption, I need another set of properties.
Right.
So we call it desalination, we call it treatment plant, whatever it is. End of the day, instead of saying water is shortage, I have enough water, I have to process it for my use case.
Right.
So that is something you are working on going forward. We are moving on from water as components, one water concept, where there is a total water, we can allocate to any use,
Right.
and then accordingly the processing will be done for that use case. That is the thought process we are having.
That
Now
is
the
wonderful work, you know.
the second part
Yeah.
is smart energy.
Okay.
That I will take shorter time, because water I thought is a very touchy subject.
Right. Yeah.
After air, water is the most essential item to live.
Exactly.
Energy is there. In energy, what we are doing is today, smart energy meter is being talked about everywhere. But what is needed is, we need a meter that can replace every place,
Right.
retrofit, whatever form factor, just to remove and refit. Because if we change the size, there is extra space. In India, rural, any extra space, a bird may put a nest, it
Right.
may become my post box, it may become my dustbin. So there are many things operationally. So the smart water, smart energy meter that we are doing will comply with standards. The advantage is, I will give a very simple advantage. Today, suppose for some reason I did not pay my bill on time.
Okay.
My connection got cut by the
Right.
lineman, as we call him. Once it disconnects, then I pay. Or something happened, I was traveling, so I
Right.
came back, I pay.
Right.
But now, even though I paid,
But I
till
still
the
don't have-
lineman comes,
Yeah.
he
Access to
reconnects,
electricity, yeah.
my power is down.
True.
Second case, there is a overload. For some reason, there is a overload in the house. My
Right.
3 compressors started running, washing machine, fridge, and maybe one more compressor,
All
AC
kinds of
started running.
appliances, yeah.
And then because of the starting simultaneously, my meter tripped. And now if I try to switch on, these 3 are again trying to switch on, and it trips again and again.
Right.
So I do not know because of which there is a trip. Other, I have to switch off one by one, then finally I have to switch on. Or if I switch on off one, whether it is enough to reduce the overload, I do not know.
Right.
So again, we do lot of experimentation, and we end up having short circuit and all, heating and all happens. So these smart meters are now we have designed in such a way, which is based on some standards, DLMS and all.
Okay.
You can monitor, it is first a two-way communication. So that means I can link my payment to my connection.
Right.
So the moment I pay, meter will be remotely switched on. No dependence
Okay.
on lineman coming
No
to your
manual
home.
dependence, yeah.
So this will make sure service uptime is high, because ultimately if lineman comes 2 days late, It is lost to the utility because 2 days I did not have power. You are not
Right.
going to get paid for it.
True.
So it is important that I give power so that energy I get my revenue
So
stream.
it's a real time.
Yeah, real time.
process,
So
yeah.
anytime you pay, instantly it can switch on.
True.
Similarly, overload, I can monitor remotely. The moment overload condition changes, remotely I can switch it on.
Right.
So I don't have to go home, check, switch on, switch off, no
Through an app
experimentation.
or something on
Yeah.
the phone. Yeah.
In fact, you can even optimize so that you don't even switch on, overload never occurs, so that load balancing happens in-house.
Right.
Now the third option is, lot of houses today have a solar rooftop, and there are
Yes.
other renewable energy materials. So how do you give credit to the power that is being supplied back to the grid?
To the grid. Right.
So this will also allow that two-way directional mechanism, and we call them AMI, automated metering infrastructure, AMI.
Right.
So it's a combination of meters and all the meters talking to a MDMS, meter
Right.
data management system. On top of it, there is a metering application where we can connect the policy for charging, subsidy, type of usage, everything.
Right.
So everything becomes a single integrated system and transparent to you. So the smart meter is just one of the hardware elements into the whole ecosystem.
Right.
So when it comes, life will be, in my opinion, very comfortable. So particularly if you take my case, what do I do to my parents who are living away? They cannot go and pay bill.
Right.
They are not using smartphones
They
to
don't
pay
have
bill.
access
So
to.
with all this technology, we have total control of what is happening. We can pay, we can make sure
From
it is
anywhere,
uptime. I can provide service to my parents without being the compulsion to go back there and pay the bill and
Sure.
things like that. So overall, this will change the way. It will save our time. We can focus on our job. This will become like a run of the mill.
And in some cases also lead to negative bills, right? Because if
Yeah,
you're
here it
giving
is
back
live.
to the grid, yeah.
Yeah. Now, you can get whatever credit and subsidy.
Right.
Everything can be part of the billing system.
True.
Yeah, there is no manual intervention. That is what is happening.
Right. So now if we come to digital governance on the ground, you have initiatives like the C-Cares. How are they bringing in a change in that, changing that scenario, changing the digital governance scenario?
CM Cares is a very, very, I will say, societal impact project. I should appreciate Ministry of Coal
Okay.
for supporting such an initiative. This is particularly about the provident fund and the pension of coal mine workers.
Okay.
Typically what happens is coal mines are a number of coal companies like Coal India Limited and all.
True. They are private companies.
No, some are PSU.
Some are,
Coal India Limited
public
is
sector
government.
also.
PSUs.
Okay.
PSUs private, both are there. Coal mines are owned by them.
Okay.
But within that mine, the digging, it is generally through outsourcing or contracting.
Okay.
There are a lot of labors involved.
Right.
And these people are mostly illiterate or blue collar, and they go under the mine, they work, they come back, they do their job. And earlier these coal mines, they will deposit their PF into a
Right.
CMPFO. It is a Provident Fund Organization of Ministry of Coal.
Okay. CMPFO.
PFO, that is the name of the office. Coal Mines Provident Fund Organization, CMPFO, under Ministry of Coal. So the challenges were, suppose I am a coal mine worker. I want to know my PF balance. In EPFO, you go online, log in, you put your number, you see.
And you get the numbers.
Or if you have pay slip, every month you know what is the contribution.
Right.
And March 31st, you get a statement also.
Yeah,
But
it's just
for a
a click
coal
away,
mine
yeah.
worker, his PF is with an organization. They maintain it. If a end user, then first he has to put a request. Someone has to go all the way, who runs the pay slip. They have to manually tell this is the balance.
Right.
And for a worker, it is a challenge because he has to do job, he has to be in the mine. The mine is normally far away from the office.
Right.
It is underground somewhere, overground somewhere. And there was a time delay. More than that, retirement cases. At the time to get the fund, paper was happening. EPFO, it is now, we have timeline. By the way, the EPFO system was also done by C-DAC.
Okay.
Yeah, the backend
Wonderful.
software done by C-DAC. So we carried it forward to the CMPFO. So with this portal, what we have done is we have linked every coal worker with their Aadhaar card on the phone.
Okay.
So anytime you can check your PF balance.
Right.
Anytime you can check your eligibility for loans or anything.
Okay.
And you don't have to go anywhere. And they can also say, if I applied for a loan, people can know exactly where my loan application is in the approval process.
Okay. They can track it.
Yeah, everything has become online. That is why it cares. That's why you put the C.
That's why
cares.
the name.
Yeah, so it's an acronym, but the cares. We care for the end user. Because for an illiterate person earlier, they will depend on their educated kids, or they go to one of the colleagues to say that भाई साहब थोड़ा मेरा एक बैलेंस पता करके बताइए. Like that they used to go, and now that person has to take time out and give it. And think about it, there are 200 coal workers. If I help, then remaining 199 will come to me.
Exactly.
There is a challenge. There is a bandwidth available to everyone. So with the CM Cares, this was actually launched by the Honorable Minister of Coal himself. So now today they are able to show lakhs of coal workers. Their balance they can track anytime, they can watch anytime. Today their settlement happens on the day of retirement.
Right.
So this is the major change. I think one major so-called digitally divided society became digital.
Okay.
So I think definitely it's a very proud moment. And the Ministry of Coal has done a wonderful job
Initiative,
working with us.
Right.
We are happy to contribute there.
Exactly. So now, skilling is a very important part of, anything. We are talking about future skills, how the future will look like. And we need to skill our, young people for that. Or even the manpower we have, we need to keep skilling them, right?
Yes.
And C-DAC has been training, people in the past 3 years. We've trained more than 50,000 people now. How is CHUC, bringing this initiative, bringing those tech skills to not just everyone, but also to underserved communities?
Very good. I will give a slightly background before coming to this. I mentioned in earlier one of the points, Y2K was a moment where India became the IT superpower and manpower supplier for the world. Right. People trusted Indian IT workforce. Even today we are. But with AI coming big time, the traditional IT workforce, we are seeing the announcement daily, because a lot of things AI is able to automate, do it faster. These numbers are going down. It is fair. In a way, coding is a blue collar job, in a way, or maybe grey collar. At some point, we should get into design and architecture rather than writing a code for logging in.
Basic coding, right?
How many years you will write code for logging in?
Exactly.
So at some point, AI is completely going to take over. It's already doing its job of automation and speeding up. So in this era, how does India keep their leadership up in this market?
True.
If you look at it, then what are the opportunities? So one opportunity is today AI still cannot write a parallel code.
Right.
And we are having the phone that you are holding in your hand, for example, probably has 8 cores or 12 cores. So it is basically a supercomputer.
Right.
But
in that sense,
we still write a code which will run on one CPU at a time, one core at a time.
Right.
Remaining 7 are not. It is like I have a highway with 8 lanes, but traffic is running on only one lane. And then we say there is a traffic jam.
Right.
Now, how can you make it run on 8 lane? Now your engine has to be that wide. Now I have to have 8 parallel things running rather than serially running. So it requires a thought process change. How do we write the code? Today, most of the colleges teach what we call algorithms that run on single computer. We called it sequential code. Now we have to make them write parallel code. It's a change of thought process.
Okay.
So almost a decade ago, we came with concept of think parallel. how to think in parallel,
Right.
not serial. So that we started. We have built some tools. We thought now it has to scale out so that the next generation workforce should know how to do parallel coding.
Right.
So that we remain on top of the world. We become still the number one programming or software talent in the world.
Right.
So that was the one of the reasons. Second, our own HPC systems are coming. So we need people who can exploit the highest capacity of the
Right,
power that is
right,
available. Because if people talk about Moore's law all the time, where you say 18 months it is doubling, but it is happening in hardware, not in software. Can you tell me one software that has doubled its speed in less than 18 months? Our utilization of software in terms of efficiency is very poor.
Right.
Because we don't utilize the hardware parallelism in software coding. So that is why we thought C-DAC stands for, this is HPC Upskilling Initiative.
Okay.
Center for HPC Upskilling. And Knowledge Enhancement. So the upskilling for our people to do parallel programming was C-DAC. Now we are running a course for about 6 months, 1 semester. It is focused on females, SC, ST students and economically weaker section.
Right.
That is the majority of students because for them we give incentive. Second is general public also can come. However, they don't get the financial incentive. Course is still available to them. So the idea is
who need it, they get.
Yeah, if somebody wants to join, they can join.
They get
But since whenever there is a subsidy financial incentive,
right.
We have more applications than we can serve. So that itself fill up the entire slot.
Right.
But the good part is with this, we have been doing a faculty development program, doing the 6 months courses for these students.
Right.
Now they are able to write program in parallel.
Okay.
We are trying our best to introduce this parallel programming as a concept, as a programming paradigm in colleges, so that the next generation of workforce is fit to use HPC, AI kind of systems.
Right.
And
They
we
have the
remain the
skills,
we remain the workforce or HRD suppliers for that. That is one. Second area, though not exactly C-DAC, where India needs manpower. Because how do we retain our superpower position in workforce? India is a country of youngest and largest system population.
True.
We need to serve the world. When we are talking about Vishwaguru,
we need to utilize that.
Yes, the leadership should come from India. We should be an inspiration. So other than the parallel programming, another area we need is actual quantum programming.
Okay.
You earlier asked once, I kind of did not answer directly, was how common man will use quantum programming. Today our universe, for example, you can write using Python.
Right.
In fact, you don't even write a code. We have made the Lego toys and all. You put the blocks, put them together, it works.
Right.
So we have this Blockly kind of programming. So you drag the blocks and put the functionality. Basically there are blocks like a puzzle. You just put your workflow by connecting the puzzles. You cannot link them wrong way. It has to be only in an approved way. Right. So your software will be generated at the back end. You don't have to write a code. So today quantum programming is that easy. But as real quantum computers are coming, we need a lot of people to write new algorithms, new software.
Right.
So that is an area again we need to develop manpower. So we are working on that. That's why through Quniverse and a sample curriculum, we are running master trainer programs in that. Then we are also looking at another area, chip design, VLSI. There, in a way, we are still designing a chip using a code only. We write programming using Verilog kind of VHDL and things like that.
Is AI involved?
Yes, I'm coming. So when do that, functionality wise, humans need to learn how to do VLSI coding.
Okay.
So that is the programming part. But that cannot be pure software. You should have some understanding of physics, materials or electronics.
Right.
So it is a hardware software combination, but still it is programming in the end. But after we do it, today a chip has got millions of gates. How to place them and connect?
Right.
That is humanly very challenging. So we call it place and route. that AI is doing a fantastic job, because AI can do a
Right.
lot of such complex activities.
Right.
So AI is having its own place, but still the basic functional design. Once you design how to put it in a given space, how to connect them, AI will take care. But designing the thing, still
That's done by
humans are the best. I'm not saying
To do
AI
that,
cannot
right.
do.
Yeah.
The most efficient, unique architectures will come from humans.
Right. And maybe not till now,
Again,
Yeah.
there we need
Yeah.
lot of manpower. That is where our chip to startup and are all helping. So these are the three areas. If we focus, our HRT will remain world class for the next 2 decades. So we can retain the leadership.
Wonderful. I mean, yeah, you rightly said that we need to use our population dividend and train them in a
Yes.
right way, so that we keep, providing the world the man force that we have. Right. So now coming to the last question of this conversation, we covered a lot during the conversation. What is when it comes to, talking about technologies, we've had AI, and then before that, quantum was very big before Gen AI kind of, came in. What is the next big thing, that is coming from C-DAC, Bangalore especially, that citizens, and people should watch out for?
Okay. The next big thing we are focusing on is opening India's largest national facility for HPC data center.
Okay.
It will support both HPC and AI.
Mm.
Today, if you June last week, a couple of weeks ago, the top 500 supercomputers were announced. In that, 2 systems, one in 240 range, another one is 310 range. We have 2 10 petaflop systems already functioning in C-DAC Bangalore, benchmarked. We are yet to dedicate to the nation, but benchmarking is done. We submitted.
2 petaflops.
Two 10 petaflop
10
systems are listed.
Okay.
If we combine them, we will break into much higher round. But we have a 10 petaflop for CPU, 10
Right.
petaflop for GPU.
Okay.
So we have 2 10 petaflops. Now we are building another larger system than this. So this year, India's largest supercomputing facility will be launched at Bangalore.
Wow,
And it will also be launching India's
big.
largest quantum computer at 108 qubit. And together they will be the largest hybrid computing facility in the world.
Largest in the world.
Because
Wow.
nobody has done the hybrid computing. Quantum guy does
Right,
quantum, HPC does
right,
HPC.
right.
We are the one who are going to
So
first
we'll
of
be the pioneers in
yes.
hybrid.
So in quantum, actually, we
that's
are
big
at par
news.
with the world, and we are ahead of the world in some areas. The other area that we are looking at something is a project, we are calling it KILA. KILA is enabling a internet kind of activity using quantum communication. So today we have something called Makan. It is a metro area quantum area network, access network. We have a 5-node setup in Chennai. As I speak, we are currently putting a long distance link to Bangalore.
Okay.
So this will be completed this year, and there will be another few nodes in Bangalore. So we will demonstrate internet connection using quantum key distribution between Bangalore and Chennai.
Okay.
And that will become the backbone. Subsequently, we will extend from Bangalore to Delhi. So that will be the first long distance quantum internet on ground. And the hardware is completely designed in India.
Totally make in India.
By C-DAC Bangalore and IIT Chennai. Together we have worked.
Wonderful.
And to some extent we have been supported by sets in some of the algorithms, which is from the office of PSA. Again, it is not C-DAC alone. It is lot of collaboration across lot of partners. So this collaboration is taking India forward. So you can look forward for some amazing announcements. And on the since you said this year, we are also waiting to announce very soon some Indian technology demonstration chip.
Okay.
We can look forward to something fantastic.
Wonderful. I think there seems to be a lot that is happening from C-DAC Bangalore, and we'll all keep our eyes, and our ears open, to, looking forward to that work, which is coming out of C-DAC Bangalore. Thank you so much for joining us today, taking out your time, and I'm sure our audiences, loved listening to you, listening to the experience that you bring, and listening to these developments and innovations that are coming out of C-DAC Bangalore. Thank you so much again.
So first of all, Sakur ji, namaste. It's a pleasure, क्योंकि आपने you asked the questions that resonated with the work that we do. Number one. Number two, I request that everyone come. We believe in co-creation and collaboration. We would like industry, academia, and other labs to work with us, because without collaboration we cannot progress.
Right, collaboration is the key. Yeah.
And third, maybe it works better in Hindi. नजर रखिए, नजर मत लगाइए. Please come support us. And we are looking forward to a wonderful, technologically advanced India. Hope we are recognized as a Vishwaguru in our inspiring leadership in technology.
Thank you once again. It
Thank
was
you,
wonderful
sir.
to have you on Code and Candid. Yeah. Thank you so much.
Thank you, sir. Pleasure.